Assalamu alaikum students and welcome to another lecture of Slate. This is Khawaja Yasin. Let's study chemistry. In the last lecture we solved a few questions of stoichiometry. So let's solve two more questions in this lecture so that we can jump on to the next topic of combustion analysis in moles. So let's look at this question. A sample of hydrated double salt, copper, ammonium. We don't have the value of X for ammonium. Sulfate, which is 2,6-hydrate. It was boiled with an excess of sodium hydroxide. Ammonia was given off. The ammonia produced was absorbed in 40 centimeter cube of 0.4 mole per dm³ hydrochloric acid. The resulting solution required this amount of sodium hydroxide to neutralize the acid. So this is again a simple question of moles. Only one trick. We don't know the X here. But know one thing. The ammonia produced, the moles of ammonia are equivalent to the moles of ammonium present in the salt. Alkali with an ammonium salt produces ammonium. So write an ionic equation between ammonium ions and hydroxide ions. So they have told you about the ions. So this is an ammonium ion reacting with a hydroxide ion, and they will make ammonia gas and water. Now that is the idea behind the whole concept. This is the concept we study in inorganic chemistry. So you can go through our lectures for inorganic chemistry for this concept. Calculate the amount in moles of hydrochloric acid present in 4 centimeter cube of 0.4 mole per dm³ of solution. Simple. N equals to C into V. So how do we calculate? We have the volume, we have the concentration. So 0.4 into 0.04, I have divided it by 1000 to make it decimeter cube. So the answer would be somewhere around 0.016 moles. This is a given value. Again, calculate the amount in moles of sodium hydroxide needed to neutralize the excess acid. Now, here, it was boiled with excess sodium hydroxide. So calculate the amount in moles of sodium hydroxide needed to neutralize the excess acid. This will be equal to the moles of hydrochloric acid left in excess. यहाँ पे हम देखते हैं अगर we have to read it again. The ammonia produced was absorbed in 40 centimeter cube of 0.4 mole per dm³ of hydrochloric acid. That's an excess. The resulting solution, the unreacted, resulting में हम unreacted की बात कर रहे हैं, required 25 centimeter cube of 0.12 mole per dm³ of sodium hydroxide to neutralize the hydroxide ions. So in this case, what are we going to do? In this case, we have this value. We need to calculate sodium hydroxide here. So N equals to C into V. So this is 0.12 into 0.025. Let me calculate the value. And that would be 3.0 into 10 raised to power minus 3 moles. Now that is the value of sodium hydroxide. Calculate the amount in moles of hydrochloric acid, ये वाले, that reacted with. अब उसने आपको बताया ये टोटल मोल्स ऑफ हाइड्रोक्लोरिक एसिड एंड यहां पे हाइड्रोक्लोरिक एसिड के वही मोल्स हैं. उसने कहा है दिस विल बी इक्वल टू द अमाउंट ऑफ हाइड्रोक्लोरिक एसिड लेफ्ट इन एक्सेस. तो ये थे लेफ्ट ओवर के अनरिएक्टेड के मोल्स. नाउ हाउ डू वी नो कि कितने हाइड्रोक्लोरिक एसिड ने रिएक्ट किया? सिंपल मैथमेटिक्स. टोटल मोल्स 0.016 minus this value, and the answer would be 0.013 moles. So this amount of hydrochloric acid reacted with ammonia initially. Calculate the amount in ammonia. अब इस केस में what do we need to know? Ammonium and acid, they have a 1:1 relationship. So this would be ammonium ratio acid. that would be a 1:1 relationship, जिसकी वजह से we get the same amount of N ammonium ions, which is 0.013 moles. Same amount, because उतनी ही अमोनिया निकल रही है जितने अमोनियम आयंस मौजूद है. देखो जितने अमोनियम है उतनी अमोनिया. And we also talked about the fact that ammonia has the same amount within acid. So acid से अमोनिया, अमोनिया से अमोनियम. That's the relationship. अब हमारे पास अमोनियम आयंस के मोल्स आ गए. The sample contained 0.43 gram of copper. Use this information and your answer to calculate the value of copper X in this. अब यहां से हम कॉपर के मोल्स इनिशियली निकालेंगे. We have the mass of copper, N equals to mass over mR. Let me tell you उसके बाद क्या होगा. 0.413 divided by 63.5. That's the mR of copper. That would be 6.5 into 10 raised to the power minus 3 moles. Now look at the formula. आपको बताया कि इस सैंपल के पास इतना अमाउंट ऑफ कॉपर है, हमने उसके मोल्स निकाल दिए. Now look at this. When we have 1 mole of this compound, we have 1 copper ratio 2 moles of ammonium. So we can make a molar ratio out of it. So if we make a ratio of copper and ammonium ions. If we have 1 copper, we have 2 ammoniums. But if we have 6.5 into 10 raised to the minus 3 moles, we are going to double the number. And that would be 0.013 moles. So these are the moles of ammonium. Because formula में पता लग रहा है 1:2. Last step. Calculate the MR of this whole compound. कैसे होगा? If you look at this, the start. So इसको निकालने का तरीका इसमें ये होगा कि हमारे पास पूरे कंपाउंड का तो मास नहीं है. That is something we don't have with us. But हमारे पास उसमें सिर्फ कॉपर का है. And 1 mole of copper means 1 mole of the compound. So अगर कॉपर का ये मास है, उसने हमें बताया कॉपर के मोल्स. So these are the moles of copper. अब हमें पता लग गया कि this is the value of ammonium and there is a relationship of 1:2 here. So हम यहां पे अमोनियम को 2 ऐड करेंगे because these two have the value and 1:2 हो जाता है. If you make a ratio out of this and this, so 1:2. You just calculate the value and that is going to be 399.7 after adding 2 after the molar ratio. Solving the last question for this lecture. Spathose is an iron ore that contains iron 2 carbonate. The percentage of iron 2 carbonate in spathose can be determined by titration with acidified potassium dichromate using a suitable indicator. अब ionic equation has been given, so burden थोड़ा सा कम हो जाता है हमारे ऊपर. We have lesser of the burden. A 5 gram sample of spathose was reacted with excess concentrated hydrochloric acid and then filtered. 5 gram sample है. And remember हम percentage की बात कर रहे हैं. The filtrate was made up to 250 centimeter cube in a volumetric flask using distilled water. A 25 centimeter cube of this sample, इसी sample का 25 हमने use किया, of the standard solution required this amount of dichromate ions. Now सबसे पहले moles of dichromate, simple, N equals to C into V. It's so repetitive. The same thing is happening again and again. These were some 10 tricky questions that we solved in these lectures. And once you can solve 2 or 3 questions, you can solve all of them. So 0.02 moles into mole per dm cube into 0.0273, which is dm cube, not the centimeter cube. So this gives us a value of 5.46 into 10 raised to the power minus 4. Simple calculation. Use your answer in 1 to calculate the amount in moles of iron 2. Now, we need to make a molar ratio. 1 ratio of chromate 1 and 6 of iron 2. So chromate ratio iron 2. We have 1 ratio 6. इसके हैं moles 5.46 into 10 raised to the power minus 4. We cross multiply. Let me multiply that with 6. 3.28 into 10 raised to the power minus 3. So remember, these were the moles in 25 centimeter cube. In the next question, the examiner asks, 250 centimeter cube में कितने moles हैं? It's a simple one. 25 ratio 250. We have done it before. अगर 25 में है 3.28, तो 250 में there will be 10 times value. So क्या हो जाएगा? 3.28 into 10 raised to the power minus 2. Simple. Use your answer in 3 to calculate the mass of iron 2 carbonate present in the sample of spethos. अब answer in 3 में हमें पता लग गया कि these are the moles of iron in this sample. But वो कह रहा है, use your answer in 3, these moles, to calculate the mass of iron 2 carbonate present in the sample. अब iron 2 carbonate में, if you make up the formula, so अगर हम formula बनाते हैं सबसे पहले, we know iron 2 carbonate is FeCO3 because it's 2. Mass निकालना है. What shall be the formula? N equals to mass over mR. Moles हमने निकाल लिए. 3.28 into 10 raised to the power minus 2 multiply by. Now let's calculate the mR. That would be 115.8 and the answer would be 3.80 grams. This is the mass of iron carbonate. Calculate the percentage of iron carbonate in this sample. अब ये है pure iron carbonate का mass. Total sample का mass हमारे पास given है ऊपर. It was 5 grams. Simple calculation again. 3.80 divided by 5.00 multiplied by 100. And the answer will be 76%. So students, these are the so-called tricky questions of moles. But once you have gone through all these 5 lectures, I am certain you would not find moles difficult anymore because they are somehow quite repetitive. So in the next lecture, we are going to talk about combustion analysis, another very important topic of AS chemistry and stoichiometry. So see you in the next lecture. Allah Hafiz.